Alright, let's look at this question 2 of exercise 4C.4. So it's basically just curve sketching, and part 1 to 3 asks us to determine the nature of stationary points and find the point inflection and interval where the function is increasing, decreasing. So here goes. Look at the f prime. This is a function in case you missed it. And you can actually factorize this. So from here we can see the critical values are 4 and -2. So the critical values 4 and -2, and the corresponding sign diagram will be something like this. If you check the sign carefully using f prime, you'll find that positive, negative, and positive. So we know that there's a local maximum here and there's a local minimum here. And it's always a good practice to calculate the corresponding y. 4 is -9. If you just check carefully, I'm referring to the solution book, of course. I get the answer quickly. So therefore, we now conclude local mean is at this point. You see, for us -9, and the local max occurs at -229. So the next part, we need to find its inflection point. So we need to derive one more time, and this should be 6x minus 6, which gives us this. So again, you see the critical values clearly is 1 for f prime, f double prime, and then do the sign diagram, and using f double prime, not f prime anymore, this f double prime, and you should get this sign diagram negative and positive. So when it's not negative, the function actually is concave. Positive is convex. Just check the theory in the text, you would understand this. So now find intervals where function is increasing, decreasing. This is fairly easy. Just refer to the f prime sign diagram, and remember this is the f double prime sign diagram. So the interval where the interval where the sign diagram is positive is increasing, so f is increasing. When x is less than -2 or x greater 4, and f decrease when here, as you can see, between -2 and 4. So next part. Okay, so find intervals where the function is convex, concave. Well, basically, this sign diagram for the f double prime tells us where the concave occurs, and and convex. So if it's negative, it's concave. So when x is greater than 1, the f is actually convex. So when it's less than 1, f is concave. So you better write down all this theory into your student reference sheet for your tests and assessment. They are very, very useful. And the last one is sketch the graph showing all important features. So first we get the y-intercept. Y-intercept occurs at f0. If you check the function carefully, so when we substitute x as 0, we'll get 1. So we're talking about the curve cutting through the point 0, 1. So now I probably won't able to do a good sketch because there's a reason, tell you why. So here 1. So I plot all the key points, the maximum, minimum. Here's the maximum. Okay, 29 is not according to scale, so don't worry, just a sketch. There's 4, and here should be -79. So there are these 2 points consider, and the critical point of here y-intercept should be this one. Yeah, here 1 when x is 1, so it's roughly here 1. So after the point 1, the curve going to be like this. It's going to be convex, and before that it's going to concave. So we actually know now probably the shape of this. Must cut the intercept, and here. Okay, and so it should be something like this. And you should try other questions from this 4C.4 using this kind of thinking and these approaches.